Hi, my name is Richard Botting, and for the last 20 years or so, it's a pleasure to have been the Managing Director of Barton Engineering. Barton has been traditionally known for its British standard conduit and accessories, and last year we introduced the UL listed EMT range, which is behind me, and this is an example of an EMT installation. Offset bends, 90-degree bends. It's a push-fit system. And this is predominantly for our customers in the Saudi market. Hi, I'm Richard Botting, Managing Director of Barton Engineering. This is an industrial bending machine that we've been supplying to construction sites for many, many years. Just like to briefly take you through the key parts. We have a tube stop, which securely holds the tube in position. We have a roller, which is in this part of the machine, which ensures that the conduit maintains contact with the former throughout the bending process, which is key. It's key. We have an aluminium former that is designed to suit the bending radius of multiple sizes of conduit: 3/4, 1 inch EMT, IMC and RMC, and 20, 25 and 32 millimeter British standard conduit. So one machine does all sizes. The tube then is formed using the bending lever, and here we have an extension lever which fits over the bender, which gives you the extra effect of leverage. So this really is an easy, simple machine and will guarantee accurate bends every single time. Hi, this is Richard. This is an EMT hand tool. In my opinion, it's not as good as the industrial machine, which we've just seen before. Why is that? Compared to the industrial machine, it's slower. The industrial machine is quicker. The industrial machine uses less energy, so operator fatigue and potential for error on this type of tool is higher, in my opinion. But it's used and it's economical. The correct way is to use it with the tool down method. It has a ribbed feature here to allow your foot to keep the tube in contact with the former at all time, and simply the product is bent. Now I'm demonstrating it without a tube, and we'll do bending with the tube later. Alternatively, it can be used in what's described as the tool up method. This is not how the tool is designed to be used, but some sites do this way. So the tube is inserted, and then the operator has to use considerable strength to bend the tube around the former. And when we've seen this, you can often have kinking, thinning, rippling, deformation of the tube. And it doesn't guarantee a perfect bend every time. But we've set up here a side-by-side comparison to bend an S-bend, so two 90-degree bends, in 3/4 inch EMT, using the industrial bending machine and using the EMT hand tool in the tool up method, which is typically used in Saudi, like I mentioned earlier, not necessarily the way the tool is designed to be used. Okay, gentlemen, let's go. So we're already on to bend 2. This gentleman is a skilled operator. He knows what he's doing. He's good at what he's doing. You can see, even though he's got strength, he's struggling. But he's produced a good bend. So the time difference between those two bends, we only did 2 bends, so the time difference perhaps doesn't look massive, but when you multiply that, when you're doing an installation of dozens of kilometers or hundreds of kilometers, the time difference is huge in terms of manpower on construction site. This gentleman has used far less energy than this gentleman, producing the same bend. He doesn't have operator fatigue. He's going to go on and produce good bends all day long. And this is an example of the finished bend. There's been no thinning, no kinking, no rippling. It guarantees 100% of the time.